Hey there, this is Mr. Wilford, and I just wanted to go over section 3 of chapter 4 with you. And this is using matrices to transform geometric figures. And this is actually a pretty cool section, and it really kind of brings, matrices alive a little bit with some geometric figures. And we could do different things with them, and really you could apply this to all sorts of things, including like computer graphics and things like that. So again, remember we're talking about matrices, so we're talking about a table of values of information. And one of the things you can do is actually take a triangle, points on a triangle. These are the vertex points A, B, C, and you can actually put those into a matrix. This is sometimes called a coordinate vertex or a vertex matrix. Coordinate matrix or a vertex matrix. And basically what you're doing here is you're having your x coordinates here and your y coordinates here. You can see these points here match up. This is point A, point B, point C. And so we can talk about this as a matrix. And what we want to be able to do is move that triangle around. So we have what's called a translation matrix. And this is used to move that triangle from its original position to a different position. And as this example down here shows, we have our triangle ABC, and we have our coordinate matrix right here. And let's say that we want to move that triangle to the right 2 and down 3. We would have this translation matrix. We would set this up, and again we want to have the same dimensions so that we can add or subtract those numbers. And so we're just adding these two matrices together, and our resultant matrix then is this new triangle ABC in red here. And we can talk about the coordinate points of that as well. And so what we've done really is just shifted this triangle over 2 and down 3, and now it has a new position. There are other sorts of ways to manipulate geometric figures. We can have a dilation, which is actually going to either blow up our geometric figure or shrink it. We're either going to expand it or shrink it depending upon what we're going to do. And this is where we would take our coordinate matrix here, and if we multiply it, for example, by 1/2, that's our scalar number. Again, that just kind of gets distributed and multiplied to each one of these elements. And our new matrix then is going to give us this new triangle, which is actually zoomed in by a 1/2. And so it's going to be a 1/2 as big inside here. If we wanted to enlarge that, then we would multiply this matrix here by a number greater than 1. We can also do some reflection, and this is an example here where if we wanted to reflect a geometric figure across the y-axis, we would multiply our coordinate matrix by this reflection matrix here. And in this example is a nice one here that shows us that we're taking this reflection matrix and we're multiplying it by this coordinate matrix of a triangle again. And so you have to remember how to multiply matrices using either just doing it outright or using a calculator and getting this matrix here. And so again, this is our original triangle, and we're reflecting it across the y, so it's like a mirror image across the y-axis, and we end up with that triangle right there. Here we have, if we want to reflect it across the x-axis, we would multiply our coordinate matrix by that matrix right there. And then finally we have a rotation matrix, and this is where we are multiplying again our matrix by another matrix, and what's going to happen is we're going to rotate our geometric figure various ways. So you can kind of look at these examples here and see how this one is rotated 90 degrees counterclockwise, and this one is rotated 90 degrees clockwise. So there's a lot of cool things you can do with matrices and geometric figures. Again, if you have any questions, please let me know. Thanks.